sort of the schematic or the rundown of what's going to go on today. A little review. We're going to get into a new chapter, chapter 6. We're going to finally get into algebra. This is your homework for tonight. These are the sections I'm going to cover today, 6.1 through 6.4. Founding Fathers Diophantus. Again, if you want to do a little report on them, I'll give you some extra points. Algebra has its roots from the Arab world. It means reduction. Now we got to get the language down. Once we know where it came from, trying to motivate you to think about this in a different light. Let's think about it in a different light, how we can make it to make our life better, make our life a little easier perhaps, right? So let's get into the verb, the vocabulary, the verbiage. Variables, I think we all know what variables are. The variables we're going to use, x, y, a, b, z. These are typical variables we use in algebra. That's easy. Constants, these are numbers without variables, just numbers. Constant is a number. I'll talk more about that as we get closer and closer to an equation. Terms, might be something that you may have forgotten. A term are numbers and variables with an operation. Here's an example of a one term, 2x. Let me write that up here. This is a one term, or it has one term. What's my number? What's my variable? What's my operation? Everybody hear that? Brittany, say a little louder.
Your number's 2, your operation is multiplication, and your variable is x.
So the number is 2, variable is x, and the operation is multiplication. Very easy, no sweat. What about this x plus 3? That's easy too, right? So again, I've got my variable, I've got my operation, I've got my number. This is a two-term expression. Uh-oh, I used another word, expression. There's another vocabulary word. Expression. What's an expression? I just used it. What is it? Brittany, you're the only one who want to play along, huh? What about you, Quarterman? What's an expression? Use your own words. What do you think? Yes, I don't care. Ricardo, what do you think? Describe something? Yeah, I guess. I mean, in the real world, in the verbiage we use, I'm expressing myself. My expressions are all about me. Me! Right? In math, what's an expression? Well, it's the whole thing. Two-term expression. So the whole thing can be expressed as a singular expression. Has a variable, an operation, and a number.
So 2x is an expression too?
2x is also an expression. We can also call it just a one-term expression. So the terms are identifying the pieces, and the expression is telling me about the whole. So that's a good one. So it gives me the whole. Gives me the whole part of some terms. Here's another expression. Let's do some examples of expressions. X squared plus 2 minus 2x minus 1. This is one expression with how many terms?
3.
So this is, right, this is one expression as a whole with 3 terms. So that's an expression. It is sort of the whole piece of some terms. Okay? So I'm going to use the word expression a lot. So if you don't have a clue on how the definition is, write it down someplace because you're going to forget. Okay? Some other terms. So that's an expression. I got that out of the way, I think. Now we want to write an equation. What's an equation? Brittany?
You put two terms together. with
Yes.
equal sign?
Excellent. Excellent. Expression is separated by two. I'm sorry, an equation is separated by two expressions. Expression with an equal sign and another expression. Could be two terms on the other side, could be three, could be 10. Okay, so all these expressions, we could have a bunch of terms. So this is a little picture graph for you. Another term. So in the expression could be two terms. Right? On one side, another term on the other. An example would be x plus 3 equals 5. This is an equation. It has two terms, or an expression on one side, and one term expression on the other. So terminology here, I'm trying to draw pictures for you, as well as algebraic representation, as well as putting in verbiage. Okay, so an equation is two expressions separated by an equal sign. So I'm trying to get the lingo down. A lot of you are kind of looking at me going, what is he going on? This is too easy. Well, yeah, but if I start talking and I start using words that you've lost, you've buried, you've misplaced, you don't use as often, this is a way that I like to do so you can hear me express myself when I talk about these things. Okay? So getting the lingo down is important. And every business has its own lingo. It's just every atmosphere, the college atmosphere has one, the household has one, they have their own terminologies, right? And so you have to get familiar with it, right? Okay, so so these are the beginning parts of algebra, or pre-algebra I want to call it. Any questions so far? Now I want to talk about, so that was here, 6.1. 6.2 talks about collecting like terms. Collecting like terms. This is in I think this is 6.1 still. Yeah, take that back, 6.2. Collecting like terms. Now we know what terms are finally, right? Kinda. Some idea of terminology. Now let's see if we know what's like and what's not like. So let's talk about like terms and unlike terms. Can you give me an example of two like terms? Janae, what do you think? Two likes. Two like terms. You know what a term is now, right? So can you give me two that are like? Is he right? Did you hear him? Didn't say I didn't hear him.
3AB plus 3AB.
Yeah, there's a 3AB. But you're making it easy. Let's say 5AB. Those are like. How?
Because they both have AB.
They both have baggage. The same baggage, I call it. If they both have the same, if both numbers have the same baggage, then they're considered like. And AB is its baggage. You know, figure a backpack and a carry-on. So, these are like terms. Put an and in the middle. What about 3x and 6x squared. Are those unlike? Should I put those in unlike, or should I put them in like?
They're the same.
Say what?
They're like, right?
I don't know. You tell me. You tell me. Some say no, some say yes. Ken, why do you say yes?
They both have X's.
They both have x's, but only one has an x.
Well, what's an X? What's X squared?
2 x's. This is the same as 6 times x times x. And I'll get into the exponent rules in a minute, but we did talk a little bit about exponents early on. Remember I said when you have exponents, it's like taking the base times itself. Right? So these are unlike. Because there's 2 x's here and only 1 x there. So these are definitely unlike. Alright? What about these two guys? Let's say 5 and 5y. These like or unlike? It's unlike. Why? Okay, so these are unlike. What about x cubed and 3x cubed?
Yeah.
Are these like or unlike? Like. Why? They have the same variable setup. They have the same baggage. Because who's in front here? Who? Invisible man. He shows up when you least expect it. He's always there. Always lurking there. 3x cubed. What about 1 over x and x?
So like.
Silence is golden. Like or raise your hand if you think you're like. Sorry. Thanks for playing. Why do you say the like? Yeah, but there's difference between an x and a denominator. Remember I told you if it's a denominator, it's like x to the minus 1. Remember we did the tens in the denominator? It's like expressing an exponent of minus 1. And that's totally different than x to the 1. So if there's nothing there, invisible man shows up. So these are very much unlike. X to the minus 1 and x to the 1. Okay? So these are examples of likes and unlikes. Now what do we do? We can't do anything with unlikes. Can't do anything with these guys. So we ignore them. Or just leave them be. Can't do anything here. We just have to leave them be. Leave them be. Okay? At least when it comes to addition and subtraction. So now we want to see what we can do to likes. We can subtract them. We can add them. Like terms. So if I have 2x plus 3x, so these are both like terms, so I can add them to get 5x. Why not 5x squared? Well, that's what a lot of people want to do. They want to add the x's too. No, all you're doing is adding the coefficients. Oops, another word. Coefficients. Coefficients. The coefficients are the numbers in front of the variables. Another definition for you. Numbers, that's another word for numbers, in front of variable. So all we do is add the coefficients. So that's what we get. And then the x comes along like baggage. And the x gets carried. Yes?
What if one of them was squared? It wouldn't still go?
Let's say we've got, Keith says, if I have 2x squared plus 3x, right? Good question. Are they like? Hell no. So what do we do with it? Leave them be. Leave them be.